Hey guys, we're going to continue here with Chapter 9. We're going to continue talking about quadratic functions. This says the graph of a quadratic function y equals ax squared plus bx plus c, where a doesn't equal 0, has the line x equals negative b divided by 2a as its axis of symmetry. If you recall from the last section, the axis of symmetry is the vertical line that cuts the parabola in half. The x-coordinate of the vertex is negative b to a. So the vertex, if you recall, is either the minimum or the maximum. So you need to copy all this down. This is the information that we're going to be using for today. Let's go ahead and keep going. Still bummed about UK not being in the tournament this year. But, you know, I just want to give a shout out to Elevators for always picking me up when I'm down. That's good, man. Elevators just always there when you need them. All right, so what is the graph of the function y equals x squared minus 6x plus 4? So I wrote out some directions for you here to follow. So the first part says find the axis of symmetry. So we'll do that first. So I want negative b, the opposite of b, which is going to be 6, over 2 times a, which is 2 times 1. And that equals 6 divided by 2. So it is 3 is the x-coordinate. Now, if I need to find the coordinates, this is my axis of symmetry right here, is x equals 3. I need to find the coordinates, so I substitute 3 in for x up here. So I would have, or right here. So I would have 3 squared minus 6 times 3 plus 4. Well, that's 9 minus 18 plus 4. That's going to be my y value. And I end up finding that that would be negative 9 minus 4. Hold on, what did I do here wrong? Yeah, so 9 minus 18 is negative 9, plus 4 is negative 5. So the ordered pair that is the coordinate of the vertex is the ordered pair 3, negative 5. So I'm going to use that information, come over here and plot that point. So 1, 2, 3, 1, 2, 3, 4, 5. And then it says find 2 other points on the graph. Well, I'm going to use points that are going to be easy for me to find. So I'm going to plug in 1. So I'm going to put 1 in here. That is going to be, I want to do mental math is my goal. So 1 minus 6 times 1 is 1. So 1 minus 6 is negative 5. Plus 4 is negative 1. So that means the point 1, negative 1 is going to be on my graph. And then I'm going to use the point 0 because that's always really, really easy. So 0 minus 0, 0 plus 4 is 4. So here is my other point. Now, if you recall, the axis of symmetry is going through this point right here. So this line cuts my parabola in half. That means if this is 2 away from my axis of symmetry on this side, then it's also right here. And if this is 3 away, then it's also 3 away over here. And that creates the other half of my parabola. So in order to graph these, step 1, find the axis of symmetry and then the coordinate of the vertex using that formula from the first slide on this. Then find 2 other points, graph the vertex and the 2 points, and then mirror it over. All right, so I need to add that. Then mirror. All right, and that will graph the function. So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's what I got. I found my axis of symmetry and then used that to find my vertex. So my vertex was 2, 2. Plot that point and then find a couple other points. I always use 0 and 1 if it's not in the vertex. It's just easier numbers to use, and then mirror them on the other side, and there's your parabola. All right, so you could use this thing called the vertical motion model. It says during halftime of a basketball game, a slingshot launches T-shirts at the crowd. T-shirt is launched with an initial upward velocity of 72 feet per second. The T-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach maximum height? What is its maximum height? What is the range of the function that models the height of the t-shirt over time? Okay, so we're going to take information from here and we're going to plug it into this. But before I get into that, I just want you to think, if a t-shirt's launched out of a cannon, it's going to go up and then it's going to come down. It makes a parabola shape. And what we're looking for is this point, which is the vertex. And we're looking for the height of that, which is going to be the y value, even though they call it h. So let's go ahead and substitute some things into this formula. So first is, I have negative, I'm going to do it up here actually. So negative 16t squared plus the v is the initial velocity, which I'm given in the problem as 72, plus c is the initial height, which I'm told it's 5 feet off the ground. Okay, so there is the function that models the t-shirt going out. So now I use this, and I need to find the axis of symmetry. So I'm going to have negative 72 over 2a, or negative 16 times 2, which equals negative 72 over negative 32, or negative 32. That's a 2. Equals 2.25. All right, so 2.25 is my axis of symmetry, but that's not what it's asking me. This is how long it takes. So how long will it take to reach 2.25 seconds? But then it says, what is the maximum height? In order to find that, I have to substitute this back into here. So that's going to be negative 16 times 2.25 squared plus 72 times 2.25 plus 5. And when I substitute all that, or just plug that into my calculator, I get 86. So 86 is the max height. So I'd say 86 feet. So 2.25 seconds, 86 feet. And this says, what is the range of the function that models the height of the t-shirt over time? Well, I know that the t-shirt is caught at 35 feet above the court. It starts at 5, so the lowest value it's going to have is going to be 5. The highest value that it's going to have is going to be 86. So I could write this as a compound inequality. I'd say h is going to be greater than or equal to 5, but less than or equal to 86. Right? Because if it starts here at 5 feet and then it lands right here at 35, the lowest value it's going to be is 5. It never gets to the ground. The highest value it's going to be is this 86. So here is the range of my data. I could write that as a compound inequality. Here's the same problem, just a minor difference. So you go ahead and pause and try that one on your own. All right, so here is what I got using the axis of symmetry, and then I put 2 seconds into the original and find that it goes 69 feet in the air. The range changes a little bit because 69 is the max height. So hopefully you got that. And that's it for today, kind of a shorter lesson. So hopefully you took good notes. I will see you all in class.